Thanks for stopping by to listen to this lecture on internationalized resource identifiers. This is a term that sounds very administrative and bureaucratic, but it's actually something that you use every day as you navigate the internet and use resources in your web browser or in programming different networked applications. International resource identifiers used to be known as URLs. Here are the key points that I want you to take away from the lecture today. First of all, the fact that web links, which are referred to or used to be referred to as uniform resource locators, are now referred to as internationalized resource identifiers. A URL becomes an internationalized resource identifier when you are able to use international characters in that URL. What they are, at a high level, IRIs are a way to find networked resources on a global internet. An IRI has several components when you write it out. But IRIs don't always refer to files, although that's kind of the way that we think about them. So what's the motivation for this? Well, you might be someone who's on the internet and you're watching a cat video and you have a friend that hears about it, that you tell about it, and that friend says, hey, can you send me the link to that hilarious cat video? And so what you're going to do for your friend is you're going to go into your browser, you're going to go to the top, the address of the video, you're going to copy it, and you're going to send it to them somehow. Maybe in a text message or maybe in an email. Some way you're going to get that address of that video to them. That address is an IRI. And if you look at it, in particular, this is one of this cat video. You just searched on the internet for it and tracked it down. And you can see that there are a lot of different components to it. You can see there's some words that you might recognize, images, GIF at the end. You can see that there's a .com in there. That sounds familiar. HTTP looks okay, looks kind of familiar. Some of those numbers in there are a little daunting, but you can see that there's a date, 2016 perhaps. And overall, we call this a link, or maybe a web link, something we're very familiar with, generally speaking. But formally, a link we will call by a different name. It has had a progression over time as to the term that we use to refer to it. We have in the past referred to it as a URL. URL stands for Uniform Resource Locator, and a URL is and was a resource and a location of a resource on the global internet. Another term that is often used to describe a link is a URI, or a Uniform Resource Identifier. These in the computer science community are often used kind of interchangeably. There's a little bit of a discussion about how they differ. Generally, though, you can think of a URI as being a more general form of a URL. One of the things that the URL and URI syntax didn't allow for, however, was international characters in the web address. And that was addressed and corrected with the introduction of a new standard called IRI, or the Internationalized Resource Identifier. Basically, this is a URI that allows international characters to be included in the web link. International characters like maybe kanji or Sanskrit, Hebrew characters or Arabic characters, a variety of different kinds of non-ASCII characters used predominantly outside the United States. These terms are often used interchangeably. I will often call something a URL just a shorthand because that is the term that, as I was being educated in computer networking, that's the term that we used. So let me provide a little bit of context for where these terms come from and why the syntax is the way that it is. Before computers were connected in the internet, each file had its own location called a file path. Now this is still present on computers today, but it dates historically back to a pre-networked time. In Windows, for example, you can refer to a file on your hard drive on your computer with a file path that maybe starts with C:\users djp3, that's my initials, desktop, and then sa.doc. And together, this would give a location on your hard drive where you can find a file called sa.doc. Now it looks like a Microsoft Word file. On a Mac, you would have a similar kind of file path, structured slightly differently. It doesn't start with a letter. Instead, it starts with a /, and then typically has a folder structure like users, djp3, desktop, and sa.doc. Again, a file on my hard drive. Each one of those terms is a folder or a subfolder. So users probably has several users underneath it. And DJP3, my particular username, probably has several folders underneath it, including desktop. And then my desktop probably has several files on it, including sa.doc. But this together identifies where in my hard drive I can find one. Linux has a similar structure to the Mac operating system because it has similar origins in the Unix operating system. Typically, a Linux file path will start with a /, the home directory, a username like DJP3, and then maybe a different kind of file rather than a Microsoft Word file, maybe an open document format like sa.odf. 3 different computers, though, with 3 different kinds of ways of specifying a file name on that particular computer. Each one of the formats for these file paths varied based on the operating system. And so when computers were networked or connected together, a standard way of finding files that worked across the internet was needed. So what IRIs do is they make the internet look like one big file system, a file system that's connected together and is independent of the particular operating system that might be serving one file or another. Before the computers were networked together, you would have to keep track of the files and the computer that they were on, and you would have to remember how each one of those different computers used file paths in different ways so that you could find the file that you cared about. When the files were networked, it became a little bit easier in order to find the files. You could at least reach out to the different computers, but they weren't standardized. Each computer networked, but still have a different file path. When the internet became more widespread and IRIs were brought into general use, at the time brought into use as URLs, the files could be accessed with the same kind of syntax regardless of which computer they were hosted on. And so the ability to find the files became a little bit easier to remember and a little bit easier to access because we abstracted away the specifics of the computer that was hosting them. So let's talk about the details of what's in an IRI. It's made of several different pieces, and there are a lot of variations that you might not have ever noticed or ever really thought about. Some you've maybe never encountered either. Browsers, especially modern browsers, are increasingly trying to hide the details of IRIs from the user because they look very technical and they look very confusing. And so you might see something like a browser here. I believe this is a Safari browser. When you put a URI or an IRI at the top, for example, a location on the Amazon.com website for a book called Universal Principles of Design, the browser hides all the details and just says Amazon.com at the top with a little padlock. But if you choose to select that so that you can share it in the same way that in our motivation we talked about sharing the cat video, if you want to share the location of this file, well then all the details of that IRI have to be revealed so that you can copy and paste it. And you can see that you have a lot more details here to examine. So let's take a look at what those details are. So what we're looking at here is a location of an information page on the Amazon.com website for a book called Universal Principles of Design, a book I kind of like. There are a lot of pieces to break down in this particular IRI that's presented to us. So let's start with the different pieces. The first piece in orange there is called the host. And the host is the name of the organization or the computer or the group of computers that stores the resource that you are referencing. Nowadays, we often associate the host with a particular company. So we think of Amazon.com as being a company, but it doesn't have to necessarily be a company. It can be any word that you're able to register, and then you can have your computer respond to that. There's some plumbing that you have to work through in order to make that happen, and other people may already have the rights to a particular name. But the host is just a name that's human readable. Amazon.com, Microsoft.com, Google.com. These are all examples of hosts that store resources. The subdomain is the small additional bit that comes before the domain name that varies. We're very familiar with, you're probably familiar with the www subdomain that precedes a lot of host names, together creating www.amazon.com. Formally, though, that www is called a subdomain, and it doesn't have to be www. The organization that owns the host can choose a variety of different subdomains to preface their host and name with, and it just allows the organization to have a different subgroup of computers answer the requests for different resources based on which subdomain you might be using. Following the subdomain and the host together, there's a portion of the IRI that's called the path. Now, conceptually, this is like the file path that exists on your hard drive, identifying which folder and which subfolders a particular resource you're interested in is located, where it's located. Conceptually, it's like a file path. You have different directories or folders, same thing, separated by a / and rooted at the first file / after the host. And so the path includes that first / and then has a variety of different components. So if we look at this one in particular, we see that that first component after the / is DP. DP conceptually is a subfolder that we're looking inside of in order to find another folder. The other folder has this name that's just a number called 159.2535879. And within those two subfolders, there appears to be a resource. And this is, the orange piece here is equivalent to a file name that starts with ref equals and ends with w1tv. That would be equivalent to the name, like sa.doc. It's equivalent to that. So together, this whole orange part, starting at the / and ending at the question mark, if one exists, is the path to the resource that you're interested in. At the very beginning is what we call the scheme. The scheme is a description of how you're asking the internet to deliver the file to you, how you're asking maybe your browser to go out and get the contents of this resource that's referenced in the IRI. You're probably familiar with common ones like http://. This stands for Hypertext Transfer Protocol. HTTPS stands for Hypertext Transfer Protocol Secure, an encrypted channel. You might also be familiar with file:. This would instruct a browser, if you put this into your browser bar, to look on your local hard drive for a resource rather than going out into the internet and getting a resource. There are lots of different schemes that are implemented in different contexts. Some you may have encountered, for example, SSH, mail-to, FTP, SFTP. These are all instructions for how to get a resource across the internet in different mechanisms and different modes. HTTPS being the most common one used in the browser today. So we specify that scheme at the beginning of our IRI. HTTPS:// is the scheme. You need to include the punctuation at the end of your scheme because different schemes have different kinds of punctuation that sort of reference different aspects of the protocol. At the end, after the path name, we encounter something called a query. A query starts with a question mark, and it is a way of specifying a component of the resource that you're interested in, a part of the resource that you're locating or identifying. It starts with a question mark, and for those of you who are familiar with programming, it's a little bit like a method call or a SQL query on a particular resource. And so in this particular case, you can see that I'm asking for some kind of resource, and it looks like I'm asking for it with a particular kind of character encoding that supports international characters called UTF-8. There's also another part of the query that's PSC = 1, and I don't actually know what that means. That's something that's used internally by the Amazon system to deliver a resource. The query consists of everything from the question mark almost all the way to the end, and there are different components that you can see within the query. We call them keys and values. Keys and values are matched together with an equal sign, and keys and values are separated with an ampersand. So this particular query has two keys. The first key is an underscore encoding, that's the key. The first value is UTF-8. So it's like saying a variable equals a value. The second variable has a key of PSC, or the second query parameter has a key of PSC and a value of 1. This query, therefore, has two keys and two values, separated by an ampersand and started with the question mark. A part that you're probably less familiar with is the port. Each IRI can also have a port, but the port is optional. When you connect to a host, you are specifying which port you want to talk to. Well, what's a port? Well, if you're familiar with maybe old movies where telephone operators would make a long-distance call by connecting a wire from one caller to another caller, making a physical connection by plugging in a wire to two different ports, it's just like that on a computer. You can reach out through the internet and connect to a server and specify which of many ports on that computer you'd like to connect to. It's like having many different cables going into one computer and picking which cable you want to connect to. Now, it turns out that there aren't lots of cables going into the back of a computer, and so this choice of port is all implemented in software. When you specify a particular port, the operating system recognizes that you're trying to connect to one particular virtual port, and it will connect you as necessary. Now, most of the time you don't see this in IRIs because there is a default port that's associated with different schemes. So, for example, the HTTP scheme has a default port of 80. So if you're using HTTP and you don't specify a colon after the domain, subdomain, and domain, then it is assumed that you are accessing 80. If you're using HTTPS and you don't put a colon and a number after it, it's assumed that you're using that protocol to connect to port 443. It's possible to use the HTTPS protocol to reach other ports other than 443, but if you want to do that, you have to explicitly specify which port you want to access, and then the computer on the other side has to be listening on that port as well. Different protocols use different ports by default, and all of them have particular defaults that are available. If you can look up on Wikipedia or something if you're interested. For example, SSH typically uses 22 by default. Here's an example at the bottom of specifying an IRI and explicitly saying that we would like to reach port 443. This is optional because HTTPS uses 443 by default. One aspect of IRIs that you probably haven't encountered very often is the ability to authenticate in an IRI itself by specifying a username and a password before the subdomain and the domain. Some schemes require authentication, and it requires it in the URL itself. And the way we include those is by attaching it to the beginning of a domain and subdomain with an @ sign. This is actually the origin of where email address syntax comes from. Before there were email addresses, there was the ability to authenticate to servers using this syntax. So for example, here you can see that I am trying to access the resource at Amazon.com using the username DJP3. Now, many websites do not restrict the access in this way. Some do, but it's something that you may encounter in different contexts. This is an example of me using my username to connect to a particular resource on Amazon. Now, in addition to that, I can specify a password with a colon. So this would be username DJP3, password @ and that information would be sent to the server. This is an aspect of IRIs that is present, and you don't actually encounter it very often, but you will occasionally. Finally, the last bit that I'd like to specify is the part at the very, very end, following the query. You can add a fragment to an IRI, and a fragment is prepended with a hashtag, and it's a particular part of a resource that you want to focus on. This is where hashtags come from, if you're familiar with hashtags in Twitter or other social media. It comes from specifying which part of a web page typically you would like the browser to focus on when the resource is loaded up. So in this case, the fragment that we're accessing is called detailed bullets _feature _div. This is a particular part of the resource that's going to be delivered to me that's going to get focused on. All right, so if we try it out and we load up that resource, that IRI address, in a browser, you can see that Amazon will deliver back this web page and it will focus on the product detail portion. And then I can scroll to the top to see the top of the web page. The reason why it went down to the product detail portion is because I put a fragment on the end to focus on a different part of the web page when it's loaded up. In this case, I didn't need to use a port because I used the default port. I didn't use a username or password because that's not the way this server works. Delivers it back, just like the cat video, I can grab this IRI and send it to someone else if I would like them to load up a web page and have it focus on the product details of this particular book. So if we put it all together and we look at a lot of different examples of some IRIs on the internet, we can see a collection of ways in which these different components of the IRI are used and not used. All 5 of these examples here use the same scheme, HTTPS. And although it's possible to include international characters, none of these actually do contain international characters. The first one goes to irs.gov with a subdomain of www, a path name of /payments/view your tax account. This is going to load up, presumably, some kind of information about your taxes. The second one is a resource at a font page, and you can see that it's asking for a resource called theme.php. That looks like a file. And specifying a query, CAT equals 115. So the key is cat and the value is 115. This actually happens to be a category of fonts. The third one is a request to search for a particular set of DVDs on a website called dvd.netflix.com. And in this particular example, you can see that the host is netflix.com, but the subdomain is not www, it's dvd. You can see that the file path is /search, and then there's this additional resource, this additional query at the end. CNN.com has a long file path ending with a file called index.html. And then bitcoincharts.com, you notice, doesn't have any subdomain at all. It's just a domain, just a host. And you can see that the resource, bitstamp.usd, has a fragment, and the fragment has a very complicated syntax there. So 5 different examples using different components of an IRI, putting them together however the server would like in order to access all kinds of different resources available to us on the internet. The general form then, a URL or an IRI is made of several pieces. The scheme, which includes the colon and slashes if that's part of the scheme. A user password if required to access a resource, prepended with an @ sign. A host, which may consist of a subdomain and a domain. An optional colon and port, specifying which part of the computer, which number of port we're going to connect to. A slash, which is the first part of the entire path that's located after the domain. And if the server supports it and requires it, you may have a query that starts with a question mark, several different keys, many different keys, and many different values separated by an ampersand. And finally, an IRI ends with a hashtag fragment. This is the concept of how we think about IRIs. We think about them as files. But the reality is that many of these resources that we're requesting on the internet may not actually be files on the hard drive the way essay.doc was on our hard drive. They may actually be created on demand. For example, if you think about an airline status or a train status web page, when you ask the internet using an IRI to get a page that describes the status of a plane or a train, what you're getting back is probably constructed on the fly. Server is accessing a series of sensors, maybe on the train or in a database, and it's constructing a web page for you that doesn't actually exist in some hard drive. It's made on the fly for you. Another way in which the concept differs from reality is that the parts that we have identified as the path also may not be referring to folders and directories on a hard drive. They may actually be part of the query system that helps us to identify what it is that we're trying to get to. They might just be used to help us create the document on demand, and essentially that path might actually be part of just an elaborate query as well. But conceptually, you can think of it as folders and subfolders. Another way in which reality differs from the concept that we're talking about is that even though we're asking just one domain for a file, there are actually probably a whole fleet of computers that are responding to that request. There's probably a set of computers that are answering that request from browsers all over the planet, farming them out to different computers in the fleet that are working for, say, Amazon.com, constructing a web page for you that looks like a file, and delivering it back through one domain name to the user that's requested it. In fact, this fleet of computers may be located in different geographic locations all over the globe. So conceptually, we're asking one computer for one file. But in reality, you may be tapping into an entire network of computers distributed across the planet that are constructing resources for you on the fly and presenting this illusion of delivering a file back to you. So, to summarize, web links are better referred to as IRIs, something that we use every day in our use of the internet. IRIs are a way to find networked resources on a global internet. An IRI has several components that we've looked at. And although we conceptualize IRIs as referring to files, they may not actually be files on a remote computer somewhere that we're accessing. So I hope that this lecture gives you a little bit more insight into the details of the syntax of the IRIs that you use every day. And as you use them, you will have a little bit more appreciation for the complexity, the thought, and the history behind this resource. Understanding that context may also help you better prepare for what the future has for this very central part of our internet infrastructure. Thank you for your attention.